Let's take a look at increasing and decreasing functions. And as soon as I get my pen working here, hello, there it goes. Okay, we got a graph going like that. Well, in college algebra, we would visually look at it and see it's increasing. And if this kept going forever, it would be increasing from negative infinity to 5. And then at 5, it's decreasing. If we look at the tangent line at points, not that I can draw a tangent line, but here's a tangent line, here's one. The slope of this will be positive. Now I hit this on the top part up here. All of a sudden my tangent line is a horizontal line. Here my slope is equal to 0. And then I get over here on this side and my slope is now negative for the tangent line. That's going to be the idea of what we're going to be looking at in this section. Our we got a horizontal tangent line where a slope is 0. Well, that's going to be where we got a change from increasing, decreasing, or vice versa. Well, let's take a look at our first problem here. It says find the critical numbers of the function. Then we got y is equal to x to the third minus 48x. And this is going to be finding the critical numbers for increasing and decreasing. So find the critical numbers for increasing and decreasing. Our first step is to find a derivative. Okay, so for this one, the derivative of this, take your power, put it out in front, lower it by 1, minus, and 48x just becomes 48. Now after we find the derivative, we're going to set it equal to 0. And solve. So we'll set the 3x squared minus 48 equal to 0. Now this one here, I can take the negative 48 to the right side, and it becomes a positive 48. We can use the square root property for this. We can divide both sides by 3. Like that. And we get x squared is equal to, what is that, 16? Now what made me think of this is the middle term was missing. We didn't have an x at all. Didn't have like a 5x or 6x. So what we do is we get the part that's squared by itself. The square root property says after you get the part that's squared by itself, you drop the squared and you put a plus or minus square root around the other side. Well, remember the square root, we're looking for a pair of somethings. Here's a pair of 4s, gives us 16. So the pair of 4s is going to come out in front as a single 4. So we got x is equal to plus or minus 4. So we got x is equal to negative 4 and x is equal to positive 4 for our critical values. Let's find the next ones. Critical numbers, critical values, they're called the same thing. Okay, so we got y is equal to x to the third minus 2x squared plus x plus 11. Now we're going to go through the same two steps. Our first step is to find derivative. So the derivative of that becomes 3x squared minus 4x plus 1. Second step is now set that equal to 0 and solve it. So we've got 3x squared minus 4x plus 1 equal to 0. Now this is the key number method. So this factors as 3x, x, 1, 1, like that. And what is this? A negative, a negative. 3x squared minus 3x. Yeah, factors that way. Zero factor property from college algebra says you get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I want to set 3x minus 1 equal to 0 and x minus 1 equal to 0. And solve each one of those. So 3x minus 1 equals 0. Take the negative 1 to the right side, becomes a positive 1. The x minus 1 equal to 0. Take the negative 1 to the right side and becomes a positive 1. Now that one's done there. This one will divide both sides by 3. And 3's cancel. And we get x is equal to 1/3. And those would be our two answers. And increasing and decreasing functions. Let me go ahead and save this. So PC increasing and decreasing functions. Page 01. PDF. And let's start a new page. Now our next problem is asking us to go a step further. They say find the critical numbers and open intervals in which the function is increasing and decreasing. Excuse me. It says use a graphing utility to verify your results. So we got y is equal to 3x squared minus 12x plus 1. And this is finding where our graph is increasing / decreasing. Now, step 1. Find the derivative. So on this particular one, take your power, put it out in front. So we got 3 times 2. That gives us 6. And then lower the power by 1, so it becomes 1. Minus 12. Again, if you got a number in x, you just drop the x. And then the 1 goes away. Step 2. Set the... Actually, I know it's a derivative. Set this equal to 0. And solve. Now remember what these are. These are our critical numbers, critical values. So these are our critical numbers. So I got 6x minus 12 equal to 0. Now to solve this one, I take the negative 12 to the right side, becomes a positive 12. Divide both sides by 6. And we get x is equal to 2. So, step 3. Using the critical numbers, build a table of intervals. Pick test cases. Plug them into your derivative. And simplify. Now, if we look at the sign of it, basically. If our sign is positive, then that means our graph is increasing. If our sign is negative, then the graph is decreasing. Okay, so our critical number is 2. Let's see what in the world I mean by this. Okay, put 2 here. And we're going to have a table of intervals. Now, clear over here is negative infinity, and clear over here will be positive infinity. So that's the table of intervals. This is going from negative infinity to 2. This one's going from 2 to positive infinity. Now we're going to pick test cases. And when I say pick a test case, we want to pick a number between negative infinity and 2. It does not matter what you pick. Try to pick something simple. 0 is pretty simple, so I'll pick 0. Now any value will work. If I'd picked x equals 1, x equals negative 50, x equals negative 57,312, that would work. Just as long as it's between negative infinity and 2. But again, pick a simple number to work with. Over here, in this interval from 2 to infinity, I want to choose a number like x equals 3 or x equals 4. Doesn't matter what you pick. Then we want to plug these into our derivative. Well, let's go see what our derivative was. Our derivative was 6x minus 12. So we got 6x minus 12. And we're going to plug these x values in. So we got 6 times 0 minus 12, which gives us a negative 12. On this one, we got 6 times 3 minus 12, which gives us 18 minus 12, which gives us 6. Okay. Using critical numbers, build a table of intervals. We just did that. Pick test cases. We did that. Plug them in derivative and simplify. We did that. Now let's look at the sign of what we came up with. If it's positive, it's increasing. If it's negative, it's decreasing. Well, this one is negative, so it's decreasing. This one is positive, so it's increasing. Now, so our answer here, decreasing here, so it's decreasing from negative infinity to 2. And then it's increasing in this interval from 2 to infinity. And those would be our answers in terms of finding out where it's decreasing and increasing. Now it talks about using the calculator to check this. If I press y equals and press clear, if we go back up to our initial problem, we had y is equal to 3x squared. So 3x squared minus 12x plus 1. And then graph. Okay, so let's go back and look at our answer. We said it's decreasing from negative infinity to 2. Well, here's x equals 2. If I go down there, it does look like it's decreasing up to that point. And then it's increasing. So that verifies our results. What they're trying to indicate with the calculator is if you just look at the calculator, you can pretty well do a quick check to see if you didn't make a math error somewhere. And let me save that. And page 2. There we go. And let's look at the next problem. So number 4. Find the critical numbers and open intervals in which function is increasing and decreasing. So same instructions. So we've got y is equal to square root of 16 minus x squared. Now we know that whenever we're taking a derivative, we don't want radicals at all. So I'm going to rewrite this as 16 minus x squared to the 1/2. Now remember our steps. First step was to find our derivative. Well, this is the chain rule. We've got parentheses to a power. So you're going to take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. and then you multiply it times the derivative of what's inside the parentheses. And that's the chain rule. Well, that gives us 1/2, and we got 16 minus x squared. 1/2 minus 1 gives us negative 1/2. And then the derivative of 16 drops away, and the derivative of negative x squared gives us negative 2x. Now we want to put these into a single fraction. Now the 2's downstairs, so it stays down there. This negative 2x goes up here. Since this is a negative exponent, we're going to move it down to the denominator, and it becomes 16 minus x squared to the positive 1/2. Well, I see the 2's cancel now. So we've got negative x over 16 minus x squared to the positive 1/2. Now, our second step here to find our critical values. Before I said set the derivative equal to 0. Here you have to do something a little bit different. When you got a fraction, what you have to do is you have to set the top part equal to 0. So I'll set the negative x equal to 0. And you have to set the bottom part equal to 0. So I got 16 minus x squared to the 1/2 equal to 0. Well, over here on the left side, negative x equals 0. I can divide both sides by negative 1. And those negatives would cancel, and 0 divided by anything is 0. So that's our first critical value. I don't think I'll ever be able to call them critical numbers, but you get the idea. Now here we have parentheses to a power. And what we can do is we can raise both sides to a reciprocal of this power. This is 1 over 2. Reciprocal is fraction flipped. So we're going to take both sides of the 2 over 1 power. Now we do that. This 2 is going to cancel. The 1's would be gone. And we got 16 minus x squared equals, and then 0 to any power of 0. Now, you're going to see this a lot. Basically, if you have something inside of parentheses to a power, you can just drop the power. It will always work out this way because 0 to any power is 0. Well, I'm going to use the square root property here. I'm going to take the negative x squared to the right side, becomes a positive x squared. Remember, you take anything across equals, the sign changes. Square root property, I'll drop off a squared, and I'll put a plus or minus square root around the other side. And we get x is equal to plus or minus 4. So those are our other two critical values. Okay, step 3. We want to build our table of intervals. Now I want to start with our smallest one, which is negative 4. Let's see, I'll put it right here. Our next one is 0, so we have 0. And then our next one is a positive 4. And we're building our table of intervals. And remember, clear over here is negative infinity, and clear over here is positive infinity. Now we want to pick our test cases. Now here I want to choose a value between negative infinity and negative 4. Well, negative 5 would be a good one. Here I want to pick something between negative 4 and 0. X equals negative 1. Here, something between 0 and 4, maybe x equals 1. Again, it doesn't matter what you pick, just as long as it's between 0 and 4. And over here, something between 4 and infinity, like 5. Now we're going to plug these into our derivative. And our derivative was negative x over 16 minus x squared, the 1/2, that's the same as, let me write that down, negative x over the square root of 16 minus x squared. You'll probably find it easier now that you're plugging in the values to put it back in the square root form. So this is square root of 16 minus x squared. Okay, let's plug in the negative 5. So we got negative 5 over square root of 16 minus negative 5 squared. Well, negative gives us a positive 5, and we have the square root of 16 minus negative 5 squared is 25. Now, notice here, 16 minus 25, that's a negative number. And a negative number inside of a square root gives us an I. We can't have an I. If I actually go up here to my original problem, if I put negative 5 up here, negative 5 squared is 25, so we got 16 minus 25. We again have a negative number inside of a square root. Basically, this interval, we don't need to worry about. Our graph does not exist here. Now, if it doesn't exist at negative 5, you can probably guess what happens at 5. It doesn't exist over here either. Now, sometimes your critical numbers tell you where something's increasing and decreasing. Sometimes it just tells you where it changes. And this one is where it changes over to undefined. Well, let's plug in these numbers now. Okay, so we're going to plug in negative 1 into negative x over the square root of 16 minus x squared. So we got negative 1 over square root of 16 minus negative 1 squared. Negative gives us a positive 1 over the square root of 16 minus 1. Now, all we really care about is what the sign is. We don't care about anything else. So this right here, this is a positive 1. 16 minus 1 is 15. Square root of 15 is positive. So this is positive, so this is increasing. Now, at the point you see what the sign is, you don't need to actually go any further. Well, let's plug in 1. So plug that in here. And actually, if you think about it, think what a square root gives you. Can the square root ever give you a negative number? This is always positive, isn't it? So then, if you put negative 1 in here, you see this is negative 1 over a positive, and negative over a positive is negative. Now, if you don't see that, plug in your value. So put 1 in for the x, and down here I got 16 minus 1 squared. Again, this gives us a negative 1 over 16 minus 1. Don't need to go any further. Negative over a positive gives us a negative, and if our sign's negative, it's decreasing. Okay, so now we can write our answer down. So this particular one is increasing. Let's see what this interval is. Negative 4 to 0. So increasing from negative 4 to 0, and then it's decreasing from 0, I think that's to 4. Let me double check it. 0 to 4. And those would be our answers. Now we could look at our graph to verify that, but I think you saw enough of that with the first one in terms of the verification. So let me save this. And let's look at our next example. Okay, so this says find the critical numbers in the open interval on which the function is increasing, decreasing. So same instructions. Okay, so we got y is equal to 1/4 x to the 4th minus 1/3 x to the 3rd minus 3x squared. Well, remember our 3 steps. First step is to find our derivative. So y prime would equal, and take your power, put it out in front, lower your power by 1. Take your power, put it out in front, lower it by 1. Take your power, put it out in front, lower it by 1. So these cancel. 1/4 times 4, so that gives us x to the 3rd. This 1/3 times 3, that cancels, so that gives us minus x squared. And then this one here gives us negative 6x. Now, step 2, set your derivative equal to 0 and solve it. These will give you your critical numbers, critical values. So we got x to the 3rd minus x squared minus 6x equals 0. We'll factor out the GCF, which will be x, and that gives us x squared minus x minus 6 equal to 0. Now what's inside the parentheses we can factor using the PSD method, and it factors as x minus 3 times x plus 2 equal to 0. Zero factor property from college algebra. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, x minus 3 equals 0, and x plus 2 equal to 0. And we get 0, we get 3, and we get negative 2. So these are our critical values. So step 3, build a table of intervals. Well, our smallest one is negative 2. So it goes first. Our next one is 0, so it comes second. Then our largest one is 3. And we're going to build a table of intervals. There we go. And clear over here again is negative infinity. Clear over here is positive infinity. We want to pick test cases. So again, we're going to pick an x value between negative infinity and negative 2. Well, negative 3 would be a good one. And here we want to choose a test case between negative 2 and 0. Negative 1 would be a good one. Here we want to choose one between 0 and 3. 1. And here we want to choose one between 3 and infinity. Maybe 4. Then we want to plug those into our derivative. What is our derivative? Let's see, x to the third. It's right here. X to the third minus x squared. So x to the third minus x squared minus 6x. So plug it into there. Here and here. Okay, so here we're going to plug negative 3 in. So we got negative 3 to the third minus negative 3 squared minus 6 times negative 3. Well, negative 3 to the third, negative 3 times negative 3 is 9, times another negative 3 is negative 27, minus negative 3 squared is 9, negative 6 times negative 3 is 18. I don't know what that is, but it's negative. I don't really care what the value is. So it's negative, so it's decreasing. Here I'm going to plug in negative 1. So we got negative 1 to the third minus negative 1 squared minus 6 times negative 1. Negative 1 to the third is negative 1 minus negative 1 squared is 1. Negative 6 times negative 1 is a positive 6. I don't know what that is, but it's positive, so it's increasing. Again, I emphasize that you do not have to solve it completely. You're just looking for what the sign is. Now here I'll plug 1 in. So I got 1 to the third minus 1 squared minus 6 times 1. That gives us 1 minus 6, which is negative, which is decreasing. And if I plug 4 in, I got 4 to the third minus 4 squared minus 6 times 4. Well, 4 times 4 is 16, times another 4 is 64, minus 4 squared is 16, minus 24. Don't know what that is, but it's positive, so it's increasing. Okay, so here it's decreasing from negative infinity to negative 2. Then it's increasing from negative 2 to 0. And then it's decreasing from 0 to 3. And then it's increasing from 3 to positive infinity. And those would be our answers. And let's save that page. There we go. And let's take a look look at our next problem. Here we got a fraction. So we got f of x is equal to 3x squared over x squared minus 9. Well, step 1. We want to find our derivative. Well, this is a quotient rule. So I'll label this as P, label this as Q. P prime would be 6x. Q prime would be 2x. Negative 9 drops away. Our formula is P prime Q minus P Q prime over Q squared. So for our derivative, we said P prime was 6x. Q we said was x squared minus 9. Minus P, which is 3x squared, times Q prime, which was 2x, over Q squared. Let me double check myself here. P prime times Q minus P times Q prime. Okay, that looks correct. Now, to simplify this, what you try to do is you try to look to see what they have in common. And when I say what they have in common, this is considered one group here, and this is considered one group, because everything's multiplication. 6 times x squared minus 9. This is one group. 3 times x squared times 2x. So looking at the first group and second group, I see they both have a 3 in common, so I can factor that out. And they both have an x. Okay, so 6 divided by 3 gives us 2. That x is gone, and we're still got the x squared minus 9. Minus, that 3's gone. I had 2 x's. I pulled 1 away, so that leaves me a single x. And then 2x. Over x squared minus 9 squared. Okay, so we got our 3x there. Now, what's left here, I'm going to multiply together. Actually, they have a 2 in common too, don't they? I didn't see that. Let me go ahead and pull that out. Okay. So then, this 2's gone, so we got x squared minus 9. Minus, that 2's gone, and we got x times x, which gives us x squared. Excuse me. Well, 3x times 2 gives us 6x. Now x squared minus x squared drops away, and we're left with a negative 9 in there. Over the x squared minus 9 squared. And that gives us negative 54x. Over x squared minus 9 to the second power. Well, that was step 1. We found our derivative. Step 2. We're going to find our critical numbers, critical values. Now remember, with a fraction, we're going to set the numerator equal to 0, the top part, and we'll set the bottom part equal to 0, our denominator. Now on this first one, I'll divide both sides by negative 54. And we get x is equal to 0. On this one on the right, remember what I said, if you have parentheses to a power equal to 0, you can just drop your power. So this becomes x squared minus 9 equal to 0. And I'll take the negative 9 over, becomes a positive 9. Use the square root property. I'll drop a square root off, and I'll put a plus or minus square root around the other side. And that gives us x is equal to plus or minus 3. And these are our critical values. So let's build a table of intervals. Our smallest number is negative 3. Our next one is 0, and then our next one is positive 3. Clear over here is positive infinity. Clear over here is negative infinity. Now we want to pick test cases. I want to choose a test case between negative infinity and negative 3, like negative 4. I want to choose one between negative 3 and 0, like negative 1. Choose one between 0 and 3, like 1. And choose one between 3 and infinity, like 4. Now we want to plug these into our derivative. So let's go up and see what our derivative was. Negative 54x. So negative 54x over x squared minus 9 squared. So plug it into that, into all these. Negative 54x over x squared minus 9 squared. And negative 54x over x squared minus 9 squared. Okay. Now think of the denominator here. X squared minus 9 to the second power. When you square anything, it becomes positive. So I don't really care about the bottom part. I know it's going to be positive in all of these. Because remember, all we're interested in is the sign. So we know the bottom's positive because it's squared. So let's do the top part. Here I got negative 54, and I'm multiply it by negative 4. Plug in our test case. Negative times a negative is positive. So we got positive over positive, which is increasing. Now here, we're going to have negative 54 times negative 1. Negative times a negative is positive. Positive over positive is positive, so it's increasing. Now here we're going to have negative 54 times 1. That's negative times a positive is negative. Negative over positive is negative, so it's decreasing. And here we have negative 54 times 4. This gives us a negative. Negative over a positive is decreasing. Now again, we could care less what those values actually are. We just care whether it's positive or negative. So this here is increasing from negative infinity to negative 3. And then it's increasing from negative 3 to something. 0. And then it's decreasing from 0 to something, positive 3. And then it's decreasing from 3 to positive infinity. What weird results? Let's go look at the graph, see if we can understand what in the world's going on with that. Plus, this is not a bad one to refresh your memory on how to input a fraction. If I press y equals, press clear. The key to putting into a fraction is if you got more than a single x or single number on top or the bottom, put parentheses around it. So put beginning parentheses, 3x squared, closing parentheses divided by beginning parentheses, x squared minus 9. Closing parentheses, and then graph. And, oh, I forgot to squared. Let's try that again. I was wondering, it's like, man, I really screwed that one up. Getting a graph is very nice for you to see if you screwed it up. So let me try to put my squared back on there. There we go. That should be an x squared. Now let me push graph. Okay. Now let's look at our results and see if we can understand what's going on. Increasing from negative infinity to negative 3. So here it is. It's increasing, going up to negative 3, wherever negative 3 is. And then it's increasing from negative 3 to 0. Right there. Then it's decreasing from 0 to 3. And then it's decreasing again. Now, you cannot say it's increasing from negative infinity to 0 because the graph doesn't even exist at negative 3, and it doesn't exist at 3 down here. So you have to write it exactly like I wrote it. So let me save that. And zoom out. There it goes. Let's take a look at our next problem. Let me shift in my seat here. Someday I'll get a comfortable seat, shaped like a throne. Okay. So I got y is equal to x squared, and then the square root of x minus 2. Same instructions. I think instructions are the same in all of these. Yeah. Okay. Well, we need to find derivative. And again, we don't work well with radicals, so we're going to rewrite the square root of x minus 2 as x minus 2 to the 1/2. Now to find the derivative, this is the product rule. So this is going to be p, and this will be q. Well, p prime will be 2x. Q prime, take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then multiply it times the derivative of what's inside the parentheses. This is a chain rule. So that gives us 1/2 times x minus 2. 1/2 minus 1 gives us negative 1/2. The derivative of x minus 2 is 1. And we want to put that into a single fraction. 2's downstairs, so put 2 downstairs. The x minus 2 to the negative 1/2. We're going to take it down below to the denominator, so it'll become a positive 1/2. And then we just got a 1 up here. Okay, so now our formula says p prime q plus p q prime. So our derivative, should have looked, y prime, not f of x prime. P prime we said was 2x times q, which was x minus 2 to the 1/2, plus p, which is x squared, times q prime, which is this. So we've got 1 over 2 x minus 2 to the 1/2. And maybe I'll just go up here to continue that. You can just follow the arrows. So I know eventually I'm going to want to get a single fraction. So let me go ahead and got 2x, x minus 2 to the 1/2. Let me put that over 1. Because if you're going to add fractions, they both should be fractions. And this one, I'll go ahead and put the x squared up on top. Now, a common denominator, if one of them is 1, the other one is your common denominator. And again, you could multiply this times this to get your common denominator. So we want to rewrite each fraction with this new denominator. Now this one already has it, so I can leave it alone. This one over here, I multiplied the bottom part by 2 x minus 2 to the 1/2, so I need to multiply the top part by the same thing. So multiply it by 2 x minus 2 to the 1/2. Whatever you multiply by the bottom, you have to multiply by the top. Well, up on top here, I got 2 times 2 gives us 4. The x remains. X minus 2 to the 1/2 times x minus 2 to the 1/2. Since they're the same, you add the exponents. So we're going to have x minus 2, 1/2 plus 1 gives us 1. Over our denominator. There we go. Now here, 4x times x is 4x squared. 4x times negative 2 is negative 8x. And I'm going to go ahead and merge them together now. I'll go ahead and put the plus x squared here, and then this down below. Um, 4x squared plus x squared gives us 5x squared minus 8x over this. Now, typically, you try to, if you got something in common, you want to factor it out. So I'll factor out an x. I guess that's the only thing they have in common. And that gives us 5x minus 8 over this. Okay, that's about as good as we can get. Now, Now I'm going to set the top part equal to 0 and the bottom part equal to 0 to find our critical values. I'll do that over here. So set the x times 5x minus 8 equal to 0. And we'll set the 2 times x minus 2 to the 1/2 equal to 0. Now this one's already factored, so this works out perfect. So we'll set x equal to 0, and we'll set 5x minus 8 equal to 0. Over here, this is another little trick. I can divide both sides by 2, and 0 divided by 2 is 0. Basically, whenever you have a number out in front of your parentheses, you can just drop the number if you got 0 on the other side. And that's where you got something to the power like this. And remember the other little trick is if you got parentheses to power, you can just drop the power. So we got x minus 2 equals 0. Okay, so this one's x equals 0. This one, take the 8 over, becomes a positive 8. And we get x equals 0, x is equal to 8/5, and x is equal to 2. And those be our critical numbers. So step 3, build our table of intervals. Looks like our smallest number is 0. Our next one is, what is our next one? This is 1 and something, so that'd be the next one. And then this one is 2. And we want our table of intervals. There's infinity. And over here is negative infinity. Now I want to pick test cases. I want to pick a value between negative infinity and 0, like negative 1. I don't know what this is exactly. It's 1 and 3/5, 1 point something. So 1's a good choice. Now here's a little bit tricky one. We got between 8/5 and 2. So I want to choose a value, and you can choose fraction if you want, or you can choose decimal. 1.9. Well, that's definitely greater than this. 1.8. Actually, I see a better one. Because if I plug in 8/5 into my calculator, it comes out nice. Let me show you. 8 divided by 5. We got 1.6. Actually, I was hoping 1.5 would work. It won't, will it? So that's 1.6. Okay, I'll use 1.9. And this one I'll choose 3. Stay away from decimals if you can, but sometimes you can't help it. Now we're going to plug this into our derivative. So let's go up and find our derivative. Where in the world's it at? Okay, this one right here. Now when I work with this, I want to put it back in the square root form. So this is x times 5x minus 8 over 2 square root of x minus 2. So x, 5x minus 8. To square root of x minus 2. So x times 5x minus 8 to square root of x minus 2. Same thing here. What was this anyway? This is 1.6, right? So let's keep that in mind. Just plug in our test cases. Now there's some parts that save you some time here. Square root of x minus 2. That'll never give you a negative number. So 2 times a positive number is still positive. So I don't need to worry about the bottom parts on these at all. Now if you don't see that, go ahead and plug it in. I mean, it's a little extra work, but if you see it, fantastic. That'll save you a lot of work. Now if I plug negative 1 in for x, I got negative 1 here times 5 times negative 1 minus 8. Okay, 5 times negative 1 is negative 5, and negative 8 gives me a negative something. Negative times a negative is positive. So this is positive over positive, so it's increasing. Now if I put 1 in here, I got 1 times 5 times 1 minus 8. 5 times 1 is 5, minus 8 is negative, times a positive is negative. So this is negative over a positive, which is decreasing. Now if I plug in 1.9, so I got 1.9, and then 5 times 1.9 minus 8. This I have no clue on. So let me go over and look. 5 times 1.9. That gives us 9.5. 9.5 minus 8 is positive. Positive times a positive is positive. So we got positive, positive, so it's increasing. This one, if I put 3 in for the x, I got 3, and then 5 times 3 minus 8. 5 times 3 is 15, minus 8 is positive, times a positive is positive. That's interesting. I didn't expect that, but to do it right. Okay. Now let's look back at our original problem. Here we have a square root of x minus 2. The domain of this. If you set your what's underneath your radical greater than or equal to 0, then our domain is x is greater than or equal to 2. So let's come down here now. X is greater than or equal to 2. That crosses this off, crosses this off, crosses this off, and the only one left is this one. So it actually becomes increasing from 2 to infinity. So even though it did a little weird thing here, we see that happen. Now I wanted to point this out because sometimes when you ignore the square root like I did here, saying it's always positive, you don't see that these over here are undefined. You know, negative 1 minus 2 is negative 3. 1 minus 2 is negative 1. 1.9 minus 2 is undefined. So I want to show this because, again, you can use those shortcuts to help you on your math, but then you have to be really careful on your domain because all of a sudden it looks like these are your answers, but 3 of them are invalid. And if I look at my graph on this just to verify that, because sometimes radicals are nasty. Come here, we'll press y equals, press clear. We got x squared. And then square root of x minus 2. And then graph. This graph isn't correct, but that's okay. We'll talk more about that later. But it is increasing, as you can see. It actually should come down and touch the x-axis. Let's save that. We're going to actually see later on in this chapter, we're going to find everything. And finding the domain, finding the intercepts, finding all that actually gives us the true picture of what the graph looks like. Let's take a look at this one. We've got f of x is equal to x minus 7 over x plus 2. Okay, so this is, we're going to find a derivative. Well, this is the quotient rule. So this is p and this is q. So p prime will be 1 and q prime will be 1. Now our formula is p prime q minus p q prime over q squared. So we'll plug those in. P prime is 1. Times q, which is x plus 2, minus p, which is x minus 7, times q prime, which is 1, over q squared. Well, that gives us x plus 2. Remember, a negative out in front of your parentheses flips the sign of everything, so it becomes negative x plus 7 over x plus 2 squared. So then, our derivative, the x's cancel. 2 plus 7 is 9 over x plus 2 squared. Let's do our test cases. But this one has another little trick like the previous problem I'm going to mention after we do it. Well, remember our steps for the critical values. You set the top part equal to 0. You set the bottom part equal to 0. Now 9 equal to 0. There's no x to solve for there, so we can just drop that. Over here, if you got parentheses to a power, you can drop the power if you got it equal to 0. Remember that little trick. And then take 2 over, and we get x equals negative 2. So we have one critical value. So here we got x is equal to negative 2. And here's negative infinity, and here's positive infinity. We want to pick test cases. I'll choose something between negative infinity, negative 2, negative 3. Something between negative 2 and positive infinity, like 0. And then we want to plug that into our derivative. Let's try writing that again. There we go. Our derivative was, what was it? 9 over x plus 2 squared. Well, think about what happens when you square something. It's always positive, isn't it? Now 9 is always positive. So this is actually positive over positive, which is increasing. Over here, something squared is always positive, and 9 is always positive, so it's positive over positive, so it's increasing. So this one's increasing from negative infinity to negative 2. And it's also increasing from negative 2 to positive infinity. Well, that one was kind of boring, plugging it in. The trick to it is, when I came up with my derivative here, and I saw this was squared, and I saw this was positive, positive over positive is always positive. So I knew it was increasing everywhere. The only place it wasn't increasing is if we look back at our original domain. Remember with the fraction, we set the denominator equal to 0. So we set x plus 2 equal to 0. And we get x is equal to negative 2. So our graph doesn't exist at negative 2. So I could have went directly, once I found derivative, using that information to this right here. Now, if you don't see that, no big deal. If you go through it, it'll be obvious once you do your test cases and so forth. But that'll save you a little bit of time if you spot that. Some people can see those, and that's great. Some people just go through all the steps each time, and that's fine too. Personally, I like steps to work 100% of the time. Although, like I said, like that, not this the problem we just did, but the problem before that, if you assume that a square root's always positive and you don't plug in your test case, kind of use that little shortcut, sometimes you run across things that appear to be increasing or decreasing when really it's undefined. Okay, so this one we got f of x is equal to negative 3x and x squared minus 4x plus 7. And this is when x is less than or equal to 1, and this is when x is greater than 1. Remember when we talked about discontinuities before? They give you the hint here. They say check for discontinuities. If I plug in 1 here, we got negative 3 times 1, that gives us negative 3. If we plug in 1 here, we got 1 squared minus 4 times 1, that gives me negative 3, plus 7 gives us 4. So these don't actually meet. They got a discontinuity at x is equal to 1. So again, what I did there is I took where it changed over, 1 was where it changed. I plugged the 1 into there, That gives us negative 3 on our first piece. And on our second piece, I plugged in 1 here. So that gives us 1 squared minus 4 times 1 plus 7, which gives us 1 minus 4 is negative 3 plus 7 gives us 4. Since they don't meet, I know there's a discontinuity there. Now, even if there isn't a discontinuity, you may still have it change from increasing to decreasing. Because if you remember piecewise functions, one piece may look like that, and another piece may look like this. So no matter what, you have to check, this is one of your critical values. You have to check it at 1. Okay, so what we're going to do is find our derivative. And this is going to seem kind of weird, because we haven't talked about that before, but for our derivative here, we take the derivative of each piece. So this would be negative 3. This one would be 2x minus 4. And this is when x is less than 1, and this is when x is greater than 1. Now we can't have the derivative at the actually at 1, so that's why I took the equal to part off. Okay. Now there is no critical values on this one. The negative 3. There's no x to solve for. So we'll just set the 2x minus 4 equal to 0. And we get 2x equals 4, or x is equal to 2. This is our critical values. And we've already indicated that you should always check where it changes over, this condition here, this 1. So we've got 2 critical values. So we got x is equal to 1, and we got x is equal to 2. And clear over here is positive infinity, clear over here is negative infinity. We want to pick our test cases. We want to choose a value between negative infinity and 1, like 0. Something between 1 and 2, like 3/2, 1.5. Something between 2 and infinity, like 3. Now we want to plug them into our derivative, but here's a little bit of tricky part. When x is less than 1, our derivative looks like this. So we're going to plug it in negative 3. So plug into the derivative. And then from 1 on, it looks like 2x minus 4. Okay, so let's see what we get. This one, there's no x to plug into, is it? It's negative, so it's decreasing. And this one, if I put 3/2 in, 2's cancel, and I got 3 minus 4, which is negative, so it's decreasing. Now the 2x minus 4 here, if I plug in 3, I get 2 times 3 minus 4, which gives me 6 minus 4, which is 2, which is increasing. So this is our answer. It's decreasing from negative infinity to 1. It's decreasing from 1 to 2. And then it's increasing from 2 to infinity. And negative 3x, that's going down. That makes sense. And yeah, that makes sense because x squared is like that. So those are our answers. So again, a little bit tricky. Sometimes when you're dealing with piecewise functions, you have to take this number here where they change over. You have to change it. Use this right here as one of your critical values, even though it didn't come from setting the derivative equal to 0. And let me save that. I'm gonna go see what my wife's cooking. I'm smelling something, food. There we go, 8. And let me stop the recorders. And come over here. Increasing and decreasing functions. And stop the recorder here.